Hello everyone, welcome to Code and Learn. In this video, we will continue to look at LeetCode problem 5, finding the longest palindromic substring in a given string. I won't go over the problem statement again as we went over it in detail in the last video. In this solution, we are going to use Manacher's algorithm to find the longest palindromic substring in a given string. Let's now look at Manacher's algorithm and how it works. Manacher's algorithm, introduced by Glenn Manacher in 1975, is a powerful solution. This algorithm capitalizes on the inherent property of palindromes, utilizing existing data to efficiently calculate palindrome lengths centered at the current character. Let's now visualize it with an example. Here we have a palindrome ABCBA. Manacher's algorithm works with odd number of characters, that is, a odd length string. The first step we usually perform with Manacher's algorithm, even if the string is already odd, is to add special characters at the odd places in the string. In our case, we are going to use hash as a special character. So let's add that. So a string becomes hash A, hash B, hash C, hash B, hash A, hash. Next, Manacher's algorithm utilizes the property of mirroring in a palindrome. The center of our current palindrome is at C. Starting with the first character, we start to calculate if there's a possible palindrome centered at this current position. As you can see, there's no palindrome in here, so we can put the length of palindrome centered at this position as 0. Next, we go to A and we can expand it both sides. So as we can formulate a palindrome centered at A, we can extend it by 1. We update the value of a palindrome starting at A to 1. Next, we have a hash again. This time, the value of a palindrome starting at this hash is 0 again. Next we go to B. We repeat the same process, and now as you can see, the number of characters we can extend from the center if the center is at B is 1 again. Next, moving on to the next hash, we can say it's 0 again. Now we are at C, and this time when we expand, we can see the whole string is a palindrome as both sides of characters are mirror value around C. So we can extend C to 1, 2, 3, 4, 5. As such, we update the value. Now this is where mirroring comes into play. If you are inside a palindrome string and there are no other palindromic substrings, you can calculate the length of palindrome substring centered at this hash using the already calculated value from the mirror. Here we can say C is the center and the right boundary of this is at this hash. To calculate the mirror, we use the formula mirror m is equal to 2 into center minus I. I is the index of current character. In this case, the index of this hash is 0, 1, 2, 3, 4, 5, 6. To calculate the mirror value, what we can do is 2 into center, which is at 5, minus 6, which gives us 10 minus 6, 4. So that's the mirror index, which is 0, 1, 2, 3, 4. We can use that to say that a palindrome starting at this hash will be of length 0. Similarly, we can do same thing for B and use the mirror value for B and so on. So we can update the values based on that mirror. For B, it would be 1, then 0, 1 and 0. And that is how mirroring is used in Manacher's algorithm. Since we are only going over the string once, the time complexity of this solution is O of n, where n is the number of characters in the string. Now let's look at the code to find the longest substring palindrome in a given string using Manacher's algorithm. Here, as you can see in our main function, we are inputting a string BABAD and then calling the longest palindrome function to get the longest palindromic substring, saving it into the result and printing the result. Let's now complete the longest palindrome function. Before we do that, we need two additional helper functions. The first one is to process the string for it to be a odd length string. So we will write func process string, which takes a string and returns the process string. Inside it, we initialize result with our special character hash, and then we range over s to add our special character at each odd index. So result plus equals string. Since it's a rune, we need to convert it to a string and then add a hash at the end as well, after which we return the result. I'm just going to add a comment to say what this function does. So process string takes a string and adds special characters, which is hash, at odd indices. Now another function that I need to use is a simple min function. What this min function does is It takes two int values a and b and returns whichever is smaller. If a is smaller than b, we return a, and otherwise we return b. Now let's fill in the longest palindrome function. First thing we do is process the string to make it all length and add our special characters. Process string is equal to process string and s. Now we need to initialize an array that we will use to store the length of palindrome centered at given characters or given index. I can say n, which is len process string, and then initialize an array p, which is of type int, and length n. Next up, I create two variables to track the center and right of current palindrome and initialize both to 0. Now we will have our main loop that iterates over each position in the process string. Inside the loop, first thing we will do is calculate the mirror position of the current position. The formula, as we went over earlier, is mirror is equal to 2 into center minus 1. Next, we perform a check to see if the current position is within the rightmost boundary of a palindrome. If I is within a palindrome, then we see the length of palindrome centered at the current position to minimum of right minus I and the mirror value. We select the min because if we move towards the end of string, if you use the mirror value, it's not going to be the right value. So we use the min value, and the min value should give the correct palindrome length if it's within the current palindrome. Else we see the value to be 0. Now what we are saying here is that the starting seed length of a palindrome at given I is equal to minimum value between right minus I or p mirror if it's within a palindrome, else it's 0. Next, we expand beyond the seed value to see if we can find a longer palindrome. For this, we need to check for two conditions. First is that we are within the length of the string. So here what we say is, since we are using the seed value and then expanding beyond the seed value, we are checking that we are within the string length. The first is to check the right end, that we are within the right extreme of the string, and the next one is to check if we are within the left extreme of the string or the end of the string. Next is the check for the palindromic string. We have already used that in previous example. So here we are saying is, if the characters match, we keep on expanding or increasing the length of palindrome. I'm just going to turn it to uppercase P so that we are consistent. So this for loop will expand to find longest palindrome at a given center, and it will use information we saved earlier. Next up, we perform another check. What this check is doing here is, if the right edge of the current palindrome that we calculated here is greater than the right we stored earlier, we need to update the center and right. That is, we need to move the center and right to match the longest palindrome we have found till now. And that's what we do here. At the end of this for loop, you would have the data to calculate the longest palindromic substring. We find the maximum value in the p array and the center index for that. So here I'm doing max len and center index, initializing them to 0, and then ranging over p, finding the maximum length along with the center index at which the longest palindromic substring is centered. Once I have those, I can calculate the start and end of that palindrome using the max length and center index value. The start is calculated by center index minus max length divided by 2. Please note, this calculation is being done with the process string, which has the special character in it, and end is start plus max length. In the end, we are using the string provided to us, not the process string, to return the longest palindromic substring. Let's now go over the solution step by step. First up, we process the string to add special characters and make it OR length. Next, we store the length of the process string and initialize the array of int value with length L. Next, we initialize two variables, center and right, to value 0. Then we iterate over the string character by character. This is self-explanatory as we are calculating the mirror of current value. Inside the loop, at each character, first we check if I or the index of current character is within the given palindrome. If that is the case, we use the already calculated value to get the seeding value for I, which is minimum of right minus I or p mirror. Otherwise, if this is the index that's out of the current palindrome, we seed it with value 0. Then we start a for loop to expand from the seed value and beyond to see if we can find a greater palindrome length. As such, first we have the condition to stay within the length of the string, and then the condition to check for palindrome. and if both match, we increase the length of the palindrome centered at a given index. If we have found the bigger palindrome, we update the value of center and right and move on to the next character. By end of this for loop, we should have the maximum length of palindromic substring stored in P. As such, we range over P to find the max length and the center index where the center of the greatest palindromic substring lies, and update the max and center length. Next, we calculated the start and end using our values, and at the end, we return the longest palindromic substring using the calculated values. Let's run our program to verify if it works. As you can see, it's working as expected. The longest palindromic substring is BAB. Since we have already looked at the code, let's try to visualize Manacher's algorithm to find the solution with the given examples, so that we can solidify our learnings. In the LeetCode question, string that is given is BABAD. Now applying the Manacher's algorithm, we can add special characters at odd indices. So this is the string we get after adding hash to odd indices in the string. Let's now mark the indices of these characters. Now we start from the first character and calculate the values. Before we start, we have center at 0 and R at 0 as well, which is the center and right boundary of the current palindrome. First, we calculate the palindrome at this hash. It has a length of 0, so we can update our array to say it stores 0 length. Then we move on to this and expand, and as such, we can update the value of length of palindrome stored at this center as 1. Since we have a new palindrome, we can move center to B and right to this boundary here. Then we move over to this to calculate a palindrome starting at this center. To start off, we use the seed value from the mirror, which is 0 in this case, so we update at 0. Then we try to expand. Since there are no expansions, we leave it at 0. Then we move on to this character. This time A is outside the right boundary of the current palindrome. As such, we try to expand again. This time we can expand and see that there's a palindrome from here to here. The seed value for this was 0, but now since we can expand, we can set it to 1, 2, 3. Now again, we update the center and R. The new center is at A and R is at this hash. As such, we move on to the next character in the string. Again, since this is within a palindrome, the seed value will be that of the mirror. The mirror in this case is this one, so we update the value to be 0. And as such, we can't expand it, so we leave it at 0. Next, we move to this. Again, we start with a seed value. This time, the seed value is 1, so we update it to 1. Then we try to expand it beyond 1. If you center the palindrome at this P, the palindrome will be starting from this hash up till this hash. We update the value again, and you can see the length will be 3. As such, we update the seed value to say it has a length of 3. Again, we will also update the center and R. Now our center lies at this P and rightmost boundary of the current palindrome is this hash. Next up, we move on to the next character. Again, since this is within a palindrome, we use the seed value, which is 0 again, so we update it and then try to expand it, but since there are no expansions, we leave it as such. Next, we move on to A. Use the mirror value. The mirror value in this case is 3. If you remember, we use minimum value between the mirror M or R minus I. So the mirror in this case is 3. R minus I is 8 minus 7, 1. And this is why we use the minimum, to prevent us from updating the wrong value. As such, we use 1 here. Next, we move on to this. Since this is still inside the palindrome, we update the value using the mirror to 0. Next, we are at D. Since it is not inside the current palindrome, we use the seed value 0. But then we try to expand and find the value to be 1. As such, again we will move the center and R to the new center and the right boundary. So when we get here, we again use the mirror value to update the value to be 0. And then if we try to expand it, there are no expansions. So we leave it at here. At the end, this is the P array that we will have. And then we can iterate over it and find the longest length, which is this and this. In the end, we can either return BAB or ABA. That's how the Manacher's algorithm works. Use the second example from LeetCode, that is CBBD, to visualize the solution for yourself. I hope you enjoyed the lesson. Until next time, happy coding.